In this video, we're going to cover converting fractions to percents and percents to fractions. Starting with converting fractions to percents, you'll notice that fractions are always a part out of a total. Part going on top, total going on the bottom. A percent is a part, but it's always out of 100. So the percent number given when we see the symbol for percent, that number always goes on top as the part, and it's out of 100. So when we're converting from fractions to percents, we just want to make sure that we get a denominator of 100, and then that numerator value is our percent. The first strategy we're going to go over is using equivalent fractions. We know that we can multiply a numerator and a denominator by the same number to create equivalent fractions. So we're going to do that specifically to get 100 in the denominator. Multiplication facts will be really helpful. You'll notice our first example, 8/20. 20 we want to get is our denominator, so we want to get from there to 100. So we have to figure out, one, what is a nice whole number to multiply by to get to 100? In this case, it's 5. 20 times 5 is 100. So we know that for equivalent fractions, we have to multiply the numerator by the same thing. In this case, 8 times 5 is 40, and we know that percents are always out of 100. If you were to get a perfect score on something, you would have 100%, so it's out of 100. In this case, 40 is out of 100, so our percent is 40%. Notice we have to write that separate, because if we were to put the percent up here, it'd be 40%, which is 40 out of 100 again. So we must write it again as 40%. Another way we could have converted 8/20 to a percent is by simplifying it first. You'll notice that both 8 and 20 are even numbers, and if we simplify it by dividing by 2 for both of them, we get a denominator that's 10. Sometimes 10 is a little bit easier to work with to get it to 100. In this case, after simplifying, we would have to multiply by 10. So we do that in the numerator and denominator, and once again, we get the 40 that we had before, which is 40%, because it's out of 100. Our second example, similar process using equivalent fractions. Now we have to figure out how to get from 25 to 100. This time, 25 times 4 is 100. So using equivalent fractions, we have to multiply the 21 times 4 as well. You can always multiply off to the side to help you. In this case, we get 84 when we multiply. The 84 is over the 100, so we know that we have 84%. And that would be our answer. Because both of these were odd numbers and we couldn't simplify 21/25, that is one way that we could have converted to a percent using equivalent fractions. The second strategy is to divide. We know that this fraction bar also means to divide. So what we can do is we can divide that fraction to convert it to a decimal, and then we can multiply by 100 to convert it from a decimal to a percent, which is what you learned in a different video. So if we start by putting Topsy in the boxy, that'll put the 5 inside the box. Graph paper can be really helpful for this. And we 8 on the outside. We're dividing by 8. We'll put the decimal here because that's going to be helpful, and put it straight up right away from the beginning. 8 does not go into 5, so we'll put a 0 there because it doesn't work. When we check that, it's 0 and we still have the 5 left over. So we have to add a 0 in order to bring it down. So now we're checking 8 into 50. We know that 6 times 8 is 48, and that's as close as we can get. So we have 2 left over, so we have to add another 0 to bring it down. 8 goes into 22 times, because 2 times 8 is 16. When we subtract, we have 4 left over, so we must add another 0. And now 8 goes into 40 5 times exactly. So we know that we've gotten our decimal. So right here, the 0 and 625 thousandths is our decimal. And in order to turn it from a decimal to a percent, we have to multiply by 100. When we multiply by 100, it's moving our decimal point 2 places, 1 for each 0, to the right. As you can see here, decimal to percent, alphabetical, 1, 2. So it'll go 1, 2 over, giving us a percent of 62.5%. So then this would be our answer. The next example, similar idea. First, we start by dividing. 7 divided by 15. We'll put our decimal down right away, add our 0, and put our decimal straight up. Because we know that 15 is not going to go into 7, so we'll put that 0 there right away. And check it, which gives us 0. So we still have the 7 left over, so we must bring down that 0. 15 goes into 70. Well, we can check 15. If we list them, it goes 15, 30, 45, 60, 75. So it went in only 4 times, which gives us 60. So when we subtract, we have 10 left over. So we must add a 0 and bring that down. After 75, since we're trying to get to 100, that would give us 90. And the next one after that would have been 105, which is too big. So it's 1, 2, 3, 4, 5, 6 times that 15 goes into 100, giving us 90. And you'll notice that we get 10 left over again. We had 10 left over here. We have 10 left over here. If we check it again, bring down a 0, we're trying to go into 100 again. Well, we know that it goes into 106 times, which was 90, and after we subtract, we have 10 again. So you'll notice that after getting 10 over and over and over again, and then checking to see if it goes into 100, each time it was a 6. And if it's going to continue being 106, it's just going to repeat over and over and over again. So we know that the 6's are going to repeat. We use the line to represent that. So this is our decimal value then. So we know that 7/15 is 4.6 with the 6 repeating. And then from there we have to multiply by 100 to convert it to a percent. So when we do this, we can keep that 6 there, which may be helpful. Multiplying by 100 moves it 2 places to the right, giving us 46 6/10 repeating percent for our answer. Here are some for you to try on your own. Now let's convert percents to fractions. Once again, we know that percent is always out of 100, and fractions are a part out of a total. One special thing that we have to remember with those fractions is that we always want it in simplest form. So we always wanted to double check that. When we're converting a percent to a fraction, we know this percent symbol is telling us out of 100. So rather than writing percent, we're going to write the 45 and actually put it over 100. Since that symbol and the fraction itself with the 100 in the denominator means the same thing. And then from here, we have to simplify using division. So in this case, because I have one number ending in a 5, one number ending in a 0, we're going to divide by 5 to start with. 45 divided by 5 gives us 9. 100. Excuse me. 45 divided by 5 was 9, so now we have to divide by the same value. 100 divided by 5 gives us 20. We want to check again to see if we can simplify any farther, which in this case we cannot, because the only number we can divide 9 by is 9, 1, and 3. 1 doesn't change it, and 9 and 3 cannot go into 20 perfectly. So 9/20 is our answer. Second example, 67%. Percent, this symbol right here means out of 100. So we're going to put the 67 over 100 to mean the same thing, and then we check to simplify. 2 doesn't work because we have an odd number. 3 doesn't work because if we add up the digits for either of them, their sum is not divisible by 3. 4 also does not work because it would have to go into 68. 5 only works for 100. It doesn't work for the 67 because it doesn't end in a 0 or 5. 6 also doesn't work because 66 would be divisible because 6 times 11. 67 wouldn't work. 7 also does not work because this would have to be 63. 8 also doesn't work because 8 times 8 is 64, and 8 more would be too many. At this point, we've already checked above what we needed to, because when we check 9 times 9, that gives us a number that is greater than our smaller number 67, and we know that all the smaller digits didn't work, so this is in simplest form. If we look at another example, we have 48% out of 100, so we put 48 over 100, and then we need to simplify. We can start with two even numbers, dividing by 2, that's okay. Dividing by the greatest common factor would be the quickest way, but this also works. We get 50 in the denominator, and we get 24 in the numerator. You'll see once again that they are two even numbers, so we can divide by 2 again, giving us 25 in the denominator and 12 in the numerator. And then from there, 12 can only be divided by 1, 2, 3, 4, 6, and 12, of which 25 cannot be divided by any of them. So 12/25 is our answer in simplest form. 80% for our final example. Percent means out of 100, so we put the 80 over 100. Then as we simplify, both end in 0, so we can divide them both by 10 to start with. When we do that, we get 8/10. Both numbers are still even, so we can divide them both by 2, giving us 4/5. And at this point, it is in simplest form because they are only one digit apart from each other. So when we're converting from percents to fractions, we put our percent digits over 100 and then simplify. Here are 4 for you to try.